Hello everybody, welcome back to our class BJTE 2023 Electric and Electronic Technology. Today we will look at the second part of resistance. We will examine the different connection of resistors, which is series connection, parallel connection, and series parallel connection. Connecting resistors. There are three important types of resistive circuits: the series circuit, as in figure A, the parallel circuit, as in figure B, and the series parallel circuit, as in figure C. A series circuit provides a single path for current flow. A parallel circuit provides two or more paths for current flow. A series parallel circuit is a combination of a series circuit and a parallel circuit. Connecting resistors in series. A series circuit contains two or more resistors and provides one path for current to flow. The current flows from the negative side of the voltage source through each resistor to the positive side of the voltage source. If there is only one path for current to flow between 2 points in a circuit, the circuit is a series circuit. The more resistors connected in series, the more opposition there is to current flow. The more opposition there is to current flow, the higher the resistance in the circuit. In other words, when a resistor is added in series to a circuit, the total resistance in the circuit increases. The total resistance in a series circuit is the sum of the individual resistances in the circuit. This can be expressed as RT equals R1 plus R2 plus R3 plus until Rn. The numerical subscripts refer to the individual resistors in the circuit. Rn is the last resistor in the circuit. The symbol RT represents the total resistance in the circuit. Example: what is the total resistance of the circuit shown in figure? In this example, we need to find the total resistance, which is RT, given in the diagram. R1 equals 10 ohms, R2 equals 20 ohms, and R3 equals 30 ohms. In order to find total resistance, RT, we need to add up R1, R2 and R3 since they are connecting in series. Therefore, RT equals 60 ohms. Example: calculate the total resistance for the circuit shown in figure. In this example, we need to find the total resistance, which is RT, given in the diagram. R1 equals 1 kilo ohms, R2 equals 4.7 kilo ohms, R3 equals 3.9 kilo ohms, R4 equals 820 ohms, and R5 equals 10 kilo ohms. In order to find total resistance, RT, we need to add up R1, R2, R3, R4 and R5 since they are connecting in series. Therefore, RT equals 20,420 ohms. Connecting resistors in parallel. A parallel circuit contains two or more resistors and provides two or more paths for current to flow. Each current path in a parallel circuit is called a branch. The current flows from the negative side of the voltage source, through each branch of the parallel circuit, to the positive side of the voltage source. If there is more than one path for current to flow between 2 points in a circuit with two or more resistors, the circuit is a parallel circuit. The more resistors are connected in parallel, the less opposition there is to current flow. The less opposition there is to current flow, the lower the resistance in the circuit. In other words, when a resistor is added in parallel to a circuit, the total resistance in the circuit decreases because additional paths for current flow are provided. In a parallel circuit, the total resistance is always less than the resistance of any branch. The total resistance in a parallel circuit is given by the formula 1 over RT equals 1 over R1, plus 1 over R2, plus 1 over R3, plus until 1 over Rn. Again, RT is the total resistance, R1, R2, and R3 are the individual, branch, resistors, and Rn is the number of the last resistor in the circuit. Example: what is the total resistance of the circuit shown in figure? In this example we need to find RT, which is the total resistance in the circuit. Given in the circuit values for R1 equals 10 ohms, R2 equals 20 ohms, and R3 equals 30 ohms. Because all resistors in the circuit are arranged in parallel, we need to use formula as stated here. By substitute all the given values in the formula we get 1 over RT equals 1 over R1, 10 ohms, plus 1 over R2, 20 ohms, plus 1 over R3, 30 ohms. Then, we need to find common denominator, which is in this case is 60. Now the formula will change to 1 over RT equals 6 over 60, plus 3 over 60 plus 2 over 60, solving for RT, and we get RT equals 5.45 ohms. Example: calculate the total resistance for the circuit shown in figure. In this example we need to find RT, which is the total resistance in the circuit. Given in the circuit values for R1 equals 1 kilo ohms, R2 equals 4.7 kilo ohms, R3 equals 3.9 kilo ohms, R4 equals 820 ohms, and R5 equals 10 kilo ohms. Because all resistors in the circuit are arranged in parallel, we need to use formula as stated here. By substitute all the given values in the formula we get 1 over RT equals 1 over R1, 1 kilo ohms, plus 1 over R2, 4.7 kilo ohms, plus 1 over R3, 3.9 kilo ohms, plus 1 over R4, 820 ohms, plus 1 over R5, 10 kilo ohms. In this example, it is difficult for us to find common denominator. So, we just divide all values on the right-hand side of equation and plus all of the values. This will give us to be equal to 1 over RT equals 0.002789. By cross multiply, we then get RT equals 358.55 ohms. Example: what resistor value must be connected in parallel with a 47 ohm resistor to provide a total resistance of 27 ohms? In this example, we need to find value of another resistor connected in parallel with resistor of 47 ohms that give the total resistance of 27 ohms. By using resistors connecting parallel formula, we get as following: 1 over 27 ohms equals 1 over R1, which is the resistor that we want to find the value, plus 1 over 47 ohms. By moving 1 over 47 ohms to the left-hand side we get the following: 1 over 27 ohms minus 1 over 47 ohms equals 1 over R1. Dividing all the values on the left-hand side, and then add all of them we get as the following: 0.0157 equals 1 over R1. Solving them and we get R1 equals 63.69 ohms. Connecting resistors in series and parallel. A series parallel circuit is a combination of a series and a parallel circuit. Figure shows a simple series parallel circuit with resistors. Notice that R2 and R3 are in parallel and that this parallel combination is in series with R1 and R4. The current flows from the negative side of the voltage source through resistor R4 and divides at point A to flow through the two branches, R2 and R3. At point B, the current recombines and flows through R1. The total resistance for a series parallel circuit or compound circuit is computed using the series formula, RT equal R1 plus R2 plus R3 plus until Rn. In the parallel formula, 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3 plus until 1 over Rn. Most circuits can be broken down to a simple parallel or series circuit. The procedure is as follows. 1. Calculate the parallel portion of the circuit first to determine the equivalent resistance. 2. If there are series components within the parallel portion of the circuit, determine the equivalent resistance for the series components first. 3. After the equivalent resistance is determined, redraw the circuit, substituting the equivalent resistance for the parallel portion of the circuit. 4. Do final calculations. Example: what is the total resistance for the circuit shown in figure? The first step is to find equivalent resistance for parallel resistors R2 and R3 using parallel formula, 1 over R equal to 1 over R2 plus 1 over R3. Substitute the values given, we get 1 over R equal to 1 over 50 ohms plus 1 over 25 ohms. Solve this equation, then we get R equals 16.7 ohms. Example: what is the total resistance for the circuit shown in figure? The first step is to find equivalent resistance for parallel resistors R2 and R3 using parallel formula, 1 over R equal to 1 over R2 plus 1 over R3. Substitute the values given, we get 1 over R equal to 1 over 50 ohms plus 1 over 25 ohms. Solve this equation, then we get R equals 16.7 ohms. In the second step, we need to redraw the circuit by substitute the parallel resistors, R2 and R3, with R a value of 16.7 ohms as in figure. Then we need to find equivalent resistance, RT, using series formula, RT equal to R1 plus RA plus R4. Substitute all the values and we get RT equal to 20 ohms plus 16.7 ohms plus 30 ohms. Solve this equation and we get RT equal to 66.7 ohms. Example: calculate the total resistance for the circuit shown in figure. The first step in this example is to identify resistors that are arranged in parallel. There are two parts where the resistors are in parallel. The first one is between R2 and R3, and the second one is between R5, R6, and R7. We need to solve these parallel branches before solving the others. The first parallel can be solved as following: 1 over R is equal to 1 over R2 plus 1 over R3. Substitute the R2 and R3 value into the equation. We get 1 over R is equal to 1 over 47 plus 1 over 62. Solve this. Then, R is equal to 26.7 ohms. Solving the second parallel, we use formula as follow: 1 over RB is equal to 1 over R5 plus 1 over R6 plus 1 over R7. Substitute R5, R6, and R7 values into the formula. We get 1 over RB is equal to 1 over 100 plus 1 over 100 plus 1 over 100, and solve the equation. We will get RB is equal to 33.3 ohms. Next we need to redraw the circuit by substitute R2 and R3 by R and R5, R6, and R7 by RB. The last step is to solve all the resistors that arrange in series. We use formula as follow: RT is equal to R1 plus RA plus R4 plus RB. Substitute all of the values, and we get RT equals 10 ohms, plus 26.7 ohms, plus 68 ohms, plus 33.3 ohms. Solving this and RT equals 138 ohms. Redraw the circuit by replacing all the resistors with 138 ohms resistor. Example: find the total resistance for the circuit shown in figure. In this figure there is branch that have resistors in parallel. However, in the upper part of the branch, there are also three resistors, R2, R3, and R4 arranged in series. The equivalent resistance of the series in the parallel portion of the circuit must be determined first. This is labeled RS. RS equals R2, plus R3, plus R4. Substitute all of the values. We get RS equals 1000 ohms. Then we need to solve the parallel resistors of RS and R5. Using the parallel formula, 1 over R is equal to 1 over RS, plus 1 over R5. Substitute all the resistors' values and solve them. We get R equals 500 ohms. By substitute the parallel resistors with R we get as in figure. Now, all the resistors are in series. Therefore, we can use series formula and get RT equals R1 plus RA plus R6. Substitute all the values and solve the equation. We get RT equals 8800 ohms. Thank you for listening to the presentation. If you should have any question, please feel free to ask. Thank you once again.